Hi, so if you're able, please print out the Chapter 8-9 handout from Blackboard, or at least have it open in front of you. In this video, we're going to start talking about drawing Lewis compounds of covalent compounds. So in the last video, we covered just writing out kind of the Lewis dot structure of an element by itself, and now we're going to go to covalent compounds. There is a section in your book on drawing Lewis structures of ionic compounds. So look at that if you want. I am not going to ask you questions about that, so feel free to skip that if you'd like. We're going to focus on covalent compounds. So let's start with a simple one, hydrogen. So hydrogen is one of our diatomics, and we're going to learn now that we start drawing Lewis structures, we're going to figure out why those diatomics always come in pairs. So for hydrogen, it just has one valence electron. So we would draw that by putting hydrogen with one little dot. And then say we're going to have two because we're going to form a bond. So if we put these guys together, we get this or this. So this represents two electrons, and this line also represents two electrons. So those are bonding electrons. And you can draw it either way. Typically, we draw it with this line to represent the bonding electrons in any given element. So in the last one, we talked about octets and how every element is trying to achieve that octet where you have 8 electrons around it. But there are actually some, especially in the first 2 rows, where they are not going to try to achieve an octet because hydrogen just has 1 proton. So if you try to put 8 electrons around it, it's going to be wildly unstable and that's not going to work. So hydrogen is actually going to follow what's known as the duet rule. And so that means that it's going to have just 2 electrons around it. Rather than 8. So when we get further down in the periodic table, they're pretty much always going to form octets. But for some of them, hydrogen, duet, and then some of them are going to be some exceptions to the rules. But for now, we'll not talk about exceptions to the rules. So let's try another Lewis structure. So water is H2O. So remember, hydrogen has just 1 electron, and then oxygen up here in the corner, we have 1, 2, 3, 4, 5, 6. So that means that oxygen has 6 valence electrons. And then another hydrogen has this. So when you're now going to kind of just smush that together, you can see if you smush it all together, so you can either do it like this or you can draw it with the lines to show the bonding. So keep in mind here we have 2, 4, 6, 8 electrons, and remember this line represents 2 electrons, so we have 2, 4, 6, 8 electrons here. Then we're going to see if everybody's following their rules. So hydrogen has 2 electrons around it, so that's our duet rule. Also following the duet rule, and then we can take a look at the oxygen. And it has 8 electrons. So then it's following the octet rule. So this is how you go through and decide if you made a stable drawing or not. Okay, so this is our Lewis structure for a water molecule. And you'll notice that I counted those electrons twice, right? Because they're sharing. So here, hydrogen has access to 2. This hydrogen has access to 2, and the oxygen has access to all the electrons because it's sharing these. All right, and so later we're going to figure out how to predict the three-dimensional shape, but for now we're just going to stick to this. So the other thing I wanted to point out are the different bonding versus non-bonding. So these are bonding electrons. And these are non-bonding electrons. So this is going to be really important when we start talking about three-dimensional shape. We'll have to figure out, you'll have to be able to look at this and figure out how many bonding electrons or bonding groups there are and how many lone pairs there are, because that's going to tell you what the overall shape is going to be. So at this point, go ahead and take out your handout and look at those guidelines for Lewis structures. So there will be some rules there. And I want you to go ahead and read through those rules and have them in front of you while we're going to be drawing Lewis structures. Okay, so let's just keep practicing drawing Lewis structures. Again, like everything that we've covered in class, we're just gonna keep going. Okay, so we're also going to cover double bonds and triple bonds. So let's look at oxygen, which we know is O2. And so now I'm gonna, all right, so the typical way that you want to draw out a Lewis structure is you say, okay, I have 2 oxygen atoms. So oxygen is over here, and we count up the valence electrons. 1, 2, 3, 4, 5, 6. So it has 6 valence electrons. So I'm going to say I have, for each oxygen, we have 6 valence electrons. I have 2 oxygen atoms, so that means 12 valence electrons. So VE means valence electrons. So then you're going to draw out your oxygens, and then you're just going to kind of follow the rules. So first you're going to bond them, and then you're going to put however many around. So you cannot include more than 12 electrons because there are only 12 available. So let's say we have 2, 4, 6, 8, 10, 12. So now you want to take a look at this and say, is this a valid Lewis structure? So I look around this guy and see that it has 2, 4, 6, 8. So that's following my octet rule, so that's good. Now let's take a look around this one. 2, 4, 6, 6. That's not good. We don't want 6. So what we can do at this point, you can start making double and triple bonds. So let's try a double bond. Now we can recount. So this oxygen now has 2, 4, 6, 8. So that's good. And this one has 2, 4, 6, 8. So remember, they're sharing those ones, so it still has access to them. So this now has 8, that's happy. So this is our valid Lewis structure of oxygen. And this right here is called a double bond, which has 4 electrons. So that means those oxygens are sharing those 4 electrons. the lone pairs belong to each oxygen, but that double bond, those 4 electrons, are being shared. Okay, so that's oxygen, and that's how we do a double bond. Now let's take a look at, we're going to do another one. So let's say we want to draw the Lewis structure for nitrogen. And we know that nitrogen is another one of our diatomic elements. So you want to go to your periodic table, find that nitrogen has 1, 2, 3, 4, 5 valence electrons, because here we have 2s2, 2p3. So we have 5 valence electrons for each nitrogen. So nitrogen has 5 valence electrons, and we have 2 for a total of 10 valence electrons. So we're going to set up our nitrogen. So let's say we just have 10. So 2, 4, 6, 8, 10. And then you can see clearly here that this nitrogen only has 2, 4, 6. That's not cool. And this one has 2, 4, 6. Also not cool. So then we can take some of these guys and move them in. So it turns out we're actually going to need a triple bond here, and you can always try it with a double bond and see if it works, but in this case you're going to find that it doesn't work. So now we're going to check each one and see if it's following the octet rule. So 2, 4, 6, 8. That's our octet rule is satisfied. And then we're going to try this other one and say 2, 4, 6, 8. All right, so he's super happy about this, right? And this one is called a triple bond. So let me rewrite it so it's not so messy. All right, so we have a triple bond, and this has 6 electrons that are being shared. So the lone pairs belong to each element, but those 6 electrons are being shared. So now I just want to point out a few things to you about single, double, and triple bonds. So a single bond this is, all right, so our single bond is the longest and weakest. Then the double bond is a little bit shorter and a little bit stronger. Then that triple bond, which we just found in nitrogen, is the shortest and the strongest. And we'll see how this bonding happens so that we can see why they're shorter and why they're stronger. But for now, just make sure you know that the single bond is going to be the longest and the weakest. Double bond is going to be a little bit shorter and a little bit stronger. And that triple bond is the shortest and strongest bond that we have. And the number of bonds is called the bond order. So that means that a single bond has a bond order of 1. Double bond, bond order of 2, and triple bond, bond order of 3. All right, so those are a little bit intro to Lewis structures and bond order. And for the next video, we're just going to go through more examples and practice drawing Lewis structures with more than 2 elements.